Hi, I'm Professor Lamb, PiPad Mathematics here again. Thank you for watching the video. This video is on a common, I don't know, puzzle piece, pentominoes or something that show up a lot of times in elementary, middle school, can even go into high school. It's a problem-solving, challenge, critical thinking type of exercise. But one of the things that you as a teacher of mathematics need to do is help build students into the process of creating these puzzle pieces, these pentominoes, and it starts with square tiles. So I'll open up a BrainingCamp activity or BrainingCamp App Color Tiles, and they have the basic four color tiles here, and you can snap them into a grid. And so what you're wanting to do is you pose a question to students to say that using only three color tiles. So they have three color tiles. 1, 2, 3. The question is how many, let me zoom in, how many different closed figures can you make when each tile shares at least one whole side with another tile? So that's the question. How many closed figures can you make using all three of your tiles where each tile shares at least one full side with another tile? So you tell them, here's a shape, and then if I put it here, that's illegal. It's not sharing a whole side, so I can't do that. I can't put it here. That's only sharing one of the vertices. So it has to either go this spot, this spot, this spot, and this spot. So whenever you join two, they have to share at least one, and then when you bring in three, they share one as well. So we do this. Here's one solution, and we can record our answer. That's one of our shapes, okay? And then we draw, or we do another one. Maybe we move this one here, and the stipulation is they're non-congruent. So you want to create how many non-congruent closed figures can you make? So here's the second one, and it's important to say non-congruent, because now what happens is when I put it here, this shape is congruent to that shape, because all I had to do is reflect it. And when I move this piece over here, that shape is congruent to the one we already made. If I take my tile and I move it here, that shape is congruent to the other one. If I take these tiles here, that shape is congruent to the other one. So with three tiles, you're limited to just these two shapes that you can make, and you want students to go through the process of exploring that and seeing why it is that these are the only two that you can make. And it's because they have to share full sides. Some students will say, well, what about making this shape? Well, it doesn't share a full side, and that's important. That's not a full side being shared. Okay. All right, now we extend it up. We move into, well, what if we had 5 tiles? Okay, now it makes it a little more fun, entertaining, if you will. I should say entertaining. I should say challenging for our students of mathematics. So how many can we make when we have 5 tiles? And so you're using all 5 tiles. You want to make how many different non-congruent closed figures can you make where each tile shares at least one full side with another tile? So there's the stipulation, and you let students explore, and they move shapes around, they try to make them here, and we see that this one's congruent to that one, so I only need to draw this one. This one's congruent as well, so I need to make different. Well, that's a different shape, that's a different shape, this is a different shape, and so you go through this process and you figure out how many do you make. Now, there is another app by another group called Ventura, and Hands-On Mathematics, and they have a Pentominoes app. And the Pentominoes app actually goes in, has a free exploration of using the apps or the shapes themselves. So we have all 12 of the shapes sitting over here to the left, and we can move them out into the right, and you can explore them. There's a lot of ways. These things have been around a while. So this shape is the F shape, and then the I shape, and the L shape, the P shape, the T shape, U, V, W, and then X, Y, and Z. So there's 12 of them. There are 12 Pentominoes shapes, and then you can have students fill in, using only 2 Pentominoes, build these congruent figures. So we're using 2 Pentominoes, and we're trying to, take these, and when I click it, it's going to fit in here, but if I fit it in there, I'm not going to be able to fit another piece in there, so that's maybe not what I need to use. And I use this one, maybe I do this, move it here, and then, oh look, that's a wonderful shape that I know I have. Where is it? Right here. There we go. And so we slide it in there, and so that fits here. Come on, that fits there. This fits here, and then you see the idea. And then you move on. You make these shapes, different explorations and ideas that you can do. But one thing that I like is to discuss, find the area and the perimeter of each of the Pentominoes figures. This helps students see that the area can stay the same, but the perimeter can change. Okay, and so whoops, here, here, and here. And when you look at these shapes, this shape right here, and this shape, and this shape, they all have an area of 5 square units, but they have different perimeters. And this one, when you're counting the perimeter, you look at all the distance around. So I have this little grid here, and I can show you the distance around the figure. Looking at the T shape, we have a perimeter that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The T shape here has a perimeter of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then the P shape doesn't have a perimeter of 12. It has a perimeter of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so you get students to ask or to determine, well, why is that? What causes it? And it's because you have shapes that are sharing more than just one side, or the T shape, you have that one shape in the middle that connects them that is sharing more than just one side, or 2 sides. There's a lot of explanation or exploration you can go into why it is, but one of the key elements there is that shapes can have the same area but different perimeter, and that is a concept in geometry. It's important that you want students to understand, and Pentominoes helps them understand it. Helps them critically build these shapes, then using the measurements of perimeter and area helps them see that shapes, non-congruent shapes, can have the same area but have different perimeters. So there you have it. Again, I'm Professor Lamb. This is PiPad Mathematics.